All right, so the last type of problem then is doing a composition where the trig functions don't match up and don't kind of undo each other. In this case, these are going to work out a little bit differently. So part of the challenge of the next test is going to be knowing how to handle each type of problem. For example, first of all, identify if this is an angle or a ratio. You should say, well, you take inverse sines of ratios, and then when you take the inverse sine of that ratio, it's going to give you an angle. But it's not a unit circle angle, and it's not a unit circle ratio, so I can't really use the unit circle to do it. So in this case, I like to do a substitution. Let's just say, let's call that angle theta. So theta is the inverse sine of 3/4. So I'm basically taking the tangent of theta. In order to evaluate the tangent of theta, I need two things. I need a triangle that has the angle theta in it, and I need to know what quadrant that angle is in. The quadrant will give me the sign, the plus or minus. All students take calculus. And the triangle will give me the value, the absolute value of the ratio. So let's figure out what quadrant it's in. So the ratio is positive, and I'm taking the inverse sine. So the inverse sine is always going to give you an angle in these two quadrants. And if the ratio is positive, it's going to be in this quadrant or this quadrant. Well, the inverse sine has got to be in these two quadrants, and it's got to be positive, so it's got to be in a first quadrant angle. So I'm going to draw a first quadrant triangle. Now this is the reference angle. This is theta bar. I'm not so sure what angle theta is. Theta could be like that, or it could be 6 times around and then to there, or positive 6 times around into there. There's a lot of different ways and things that theta could be. I don't know what theta is, but I know the reference angle is this, and it forms this triangle. And if the sine is 3/4, then the opposite is 3, the hypotenuse is 4. I was going to say this is a 3, 4, 5 triangle, but it's not. A squared plus 3 squared equals 4 squared. A squared plus 9 equals 16. A squared equals 7. So this is the square root of 7. Plus or minus the square root of 7, but because it's to the right, it's a positive, so that's my triangle. And I'm in the first quadrant. Now, I need to find out what is the tangent of theta. Well, the tangent of theta is square root of 7/4. And it's positive because it's in the first quadrant. Okay? So, figure out where the angle is, draw the triangle, and use a combination of your right triangle with your quadrant to figure out the problem. Okay? But start it out with a substitution. All right, so this is an angle. We'll call it theta. So theta is the arc tangent of -5, 6. I just need to take the cosine of that angle. Okay? So let's figure out where that angle is. All students take calculus. The tangent ratio is negative. So it can't be in this quadrant and it can't be in that quadrant. It's got to be in one of these two quadrants. The inverse cotangent will give you an angle in these two quadrants. So that rules out this one. So this angle must be a fourth quadrant angle. So draw your triangle in the fourth quadrant. This is theta bar. It's the reference angle for theta. And the ratio of the tangent is 5/6. That's opposite over 6. And it might help you to tack a sign on here, so it'll help us with the signs here, I guess. That's a +6 because it's to the right, and this has got to be a -5 because it's down. So let's find the hypotenuse. 6 squared plus 5 squared equals c squared. 36 plus 25 equals c squared. So that's 61 equals c squared. So c squared equals plus or minus the square root of 61. Now, if you're going to set up the signs like this, the hypotenuse has always got to be positive. So make that a positive square root of 61. Okay? All right, so what is the cosine of theta? I got my triangle. It's in the right quadrant. I got the signs on it correctly. Cosine is adjacent over hypotenuse. So 6 over the square root of 61. And you see that's positive, and cosine's positive in that quadrant, so we're good. I don't care about rationalizing. I care about everything else. By the way, if these are on a test, and if you get it right, I'll give you credit for it. But if you don't get it right, and this is a 5-point question, and I don't see a substitution, and I don't see a triangle drawn in a certain quadrant with sides on it, you're going to get a -5. All right? You do this, you do this, you do this, and you get this wrong, you're going to get a -1. Of course, if you do all of this right, you probably won't get that wrong. All right, so now these were given actual ratios. Here we're given variable ratios. And this, you might say, well, why do I need to know any of this stuff? But these types of problems you kind of encounter in calculus. So that's kind of why we're doing them. Express the following expression in a form without trig functions. Well, you're taking the inverse cosine, so this is still a ratio. It's just a ratio with a variable. So this is going to be an angle. So let's call that angle theta, arc cosine of 3x over 1. I need to take the tangent of that angle. Draw it. All students take calculus. Problem here is I don't really know what x is. I don't know if x is positive or negative. But I do know the inverse cosine is going to give me an angle in one of these two quadrants. So basically, if x is positive, then I'm over here, and this is my theta bar. If x is negative, then I'm over here, and this is my theta bar. So we kind of got two cases. Let's just set it up as 3. It doesn't really matter, just pick one, I guess. Cosine is adjacent over hypotenuse. So let's find this unknown side. 3x squared plus a squared equals 1 squared. A squared equals 1 minus 9x squared. So a is equal to plus or minus the square root of 1 minus 9x squared. However, because these are both positive, they're both up, I don't really need that negative, so I can just say 1 minus 9x squared square root. And it's going to be the same for both. You only really need to do one. So what is the tangent of theta? The tangent of theta is opposite over adjacent. It is the square root of 1 minus 9x squared over 3x. And everything's going to work out well on this one. All students take calculus. So if x is positive, if x is positive, then I'm in the first quadrant, right? I'm in quadrant 1. And if I'm in quadrant 1, then the tangent needs to be positive. If x is positive, this expression is positive, so it works. If x is negative, then I'm in quadrant 2, because this is 3x. Now it's going to be negative. And if I'm in quadrant 2, then the tangent should be negative. But if I'm in quadrant 2 and if x is negative, then this expression is negative, because the square root's positive over a negative is a negative. So the signs work themselves out. That's going to work out nice when you have x on the top. If you have x on the bottom, it's not going to work itself out so nice. So these are really difficult. This will be the hardest question on the test. Let's just set it up, do the same thing. This is my angle theta. So let's draw the stuff. So inverse cosine is going to give me an angle in either all students. It's going to be in quadrant 1 or quadrant 2. So it's going to be either this or it's going to be this. Let's just do this one here. Theta bar. Cosine is 1 over x. 1 squared plus a squared equals x squared. A squared equals x squared minus 1. So a is equal to plus or minus the square root of x squared minus 1. So this is the square root of x squared minus 1. This is 1. Technically this is negative 1. Square root of x squared minus 1. And you can kind of see why this is going to have, we're going to have problems here. I'm saying my ratio is 1 over x. This is the one that, well, who cares? Let's just do it. What is the sine of theta? Sine of theta is opposite over hypotenuse. So there's my expression. However, we need to make sure that our signs, our plus and minuses, are okay. For example, if x is greater than 0, then I'm in quadrant 1. And if I'm in quadrant 1, then my sign should be positive. If x is positive, then this expression is positive and everything is good. However, when x is less than 0, I'm in quadrant 2. So if x is negative, can you see that this ratio is going to be negative? The square root is positive. If you take a positive divided by negative, you get a negative. However, the sign of this second quadrant angle needs to be positive. So I need to make this thing always positive. I put an absolute value around that x, it makes it positive. If you're saying, dang, is he going to give me that on the test? The answer is maybe. Last one. Let's theta equal inverse sine of 1 over 2x. Draw it. All students take calculus. The inverse sine is going to give me an angle in these two quadrants, quadrants 1 or 4. So I could be up here, or I could be down here. I don't normally draw both. I just do one and then think about it at the end. So this is theta bar. Now the sine is 1 over 2x. I need to find this third side. So 1 squared plus a squared equals 2x quantity squared. Pythagorean theorem. A squared equals 4x squared minus 1. So a is equal to plus or minus the square root of 4x squared minus 1. So this is the square root of 4x squared minus 1. I need to take the tangent of this. That is the tangent of theta. So the tangent of theta is 1 over the square root of 4x squared minus 1. Now we got problems here as well, because so let's look at the cases. If x is greater than 0, then I'm in quadrant 1. And the tangent of theta should be positive. So if x is greater than 0, this is positive. In fact, 1 divided by the square root is always positive, so I'm good. However, if x is less than 0, then I should be in quadrant 4. And the tangent of theta in the fourth quadrant should be negative. But if x is negative, this quantity will never be negative. So we have a problem. Sometimes it's supposed to be positive and sometimes it's supposed to be negative. I will actually accept this on a test. If you just say plus or minus, like say sometimes it's positive, sometimes it's negative, plus or minus, that's kind of okay. The real answer though should be a piecewise function. It's 1 over the square root of 4x squared minus 1 when x is greater than 0. And it's negative 1 over the square root of 4x squared minus 1 when x is less than 0. What is it if x is equal to 0? Ah, sweet, we can't have x equal to 0. So this is technically the right answer, but I'll accept this. All right, I know these last two are very tricky. I would really say focus on these, and this one. Those were not tricky, but you need to know how to do those. These here even if I were to put this on here, that absolute value might only be worth 1 point. So even if you forgot about all the cases and all the craziness, you'd only lose 1 point, okay? Anyway, I know these are tough. All of these videos are the topics that make this next test difficult. Okay, so work at it, practice it, and when we get back, we'll practice it some more.